Hello everyone, and welcome to the first tutorial. I am going to go through the process of modeling a building for energy simulations, and it's going to be covered in three parts. The first part will be setting up the model and going through interface basics, etc. The second part will be about setting up the simulation within Grasshopper for daylighting analysis. And then the third part will be about manipulating the design on the facade and evaluating the existing site and context. Okay, let's begin. So first, within Rhino, I'm just going to grab my plan, and the plan that I have is just a fire plan. So use the picture import if you missed that, just here. And once that's in, let's just check our units. We want to be working in meters for this because a large scale model, and precision is fine. Okay. Yes. Whoa, that got very small. We can just scale that up again. That's fine. Okay. So what we need to do is figure out what scale this building is. So we're looking for little indicators. So say for instance the stairs. Those stairs should be around about 1200 long. I'm just going to do this rough for now. Wow, that was so close. That's incredible. All right. Let's just scale it down there. Okay, now let's have a look at our layers once we've got this to scale. And I'm going to change the picture to this layer. Just this image reference. And then I'm going to lock that. So now if I click, it's not going to move. I like to turn off my grid. We can hit F7 for that, just so it's there's not too much visual noise. You can also like nicely crop this image before you bring it in Photoshop or something, but I'm just going to run with this as it is. We're going to go to layer 2. Just want to create a sketch layer, so I'm just going to use a polyline over here. If I hover over here, we left click, then we can so let's try and not miss some of the nuances of how I've set this up. So there's an ortho snap down here, and if you can't see these, you can right click and but you could play around with this until you find it should be in the default settings anyway. And if you can't see these snaps, make sure your O snap is bold like this. So this disables the snaps in my case, but if you can't see the snaps, then you can click on this and you'll be able to see them. Okay, so the way that I model, the reason why I came down here was because if I hit the ortho, you might be used to this in CAD software, it'll snap to the 90-degree directions without me pressing any of the keys. I don't really like this because I hardly ever model things in ortho, it's very rare. only for like starting out and grids and that sort of thing. But this is a relatively simple model, so you could use ortho if you like it. But the way I do it is I put ortho off, and if I need a 90-degree snap, I just hold down shift, like so, and it'll do that. Another neat trick is to hit tab when doing that, so then I don't have to hold any keys or anything, and it will literally snap to that direction. And then if I wanted to type in a length for that line, it looks like this is about 13.5-ish or 13.4. So I'm going to type in 13.4 rather than approximating the dimension. Type it in so that we don't get any sort of weird decimals. The same deal for here, so we get 19.2. Okay, so shift tab 16.4, sorry, 6.4. Okay. 3.6, 7. How do we do? Oh wow, we did very well. So if you meet up at the end, that's when you know you've modeled something well. It's a little check. Now my dimensions are going to be fairly off because my photo of my plan is not very good. So we can make a little bit of a correction here and there if we think we need to average out these sort of things. For the purposes of what we're doing, it's not overly critical, but let's just nudge this a little bit. So with this curve, you can select it and press F10. Okay, so it turns out that F10 actually stops the recording. So yeah, I've started again, but yeah, F10 turns the points on. So now we can sort of manipulate that the boundary to match the plan. Now you'll notice that I've got a series of new layers here. That's because I accidentally did not record the previous bit. So I'm just going to do a bit of a review of what I've done. So we've created primary and secondary grid, apartments layer, and the core with all of its subcomponents within the core. And within each of those layers, there's some curves describing the grid, for instance. And it looks like I've just missed a grid line there, so I'm going to recreate. Yep, it was in the secondary grid. There we go. And now using the primary grid, which represents the major internal walls dividing each of the apartments, we can use that as a bit of a reference to create a secondary grid in order to describe some of the more detailed components of the plan. And we create that secondary grid by just offsetting lines from the primary grid. So in the apartments layer, I've created a perimeter for each of the apartments. This creates a nice reference for calculating the area of the apartment and just defining its boundaries. The way I've created these apartments is by selecting each of the grid lines and the external wall outline and created a curve Boolean operation on them. aliases, CB, you could use as well if you've used those. And just make sure the combined regions is on, and select all of the regions within the grid that the apartment belongs to, and then confirm it with a right click, and you'll be able to extract the external perimeter of all of those regions to create your apartment boundaries, like so. Next step is to detail some of the core components. So I just created a curve boolean based on the other apartments to create a perimeter for the overall core, and then used the primary secondary grids to create those subcomponents of the core. We've got laundry, services, the lift, stairs, and the corridors. So now we are ready to reference all of this geometry into Grasshopper in order to generate some three-dimensional geometry based on our building layout in plan. And we'll be modeling it for daylighting analysis specifically, but we want to be proactive in creating a model that is usable for energy simulations as well.